We are going to be looking at interpreting parts of graphs. So let's go over some key vocabulary. Linear is a graph that is a straight line. They can be diagonal, vertical lines, horizontal lines. It's just a straight line. Nonlinear are graphs that is not a straight line. So linear can be horizontal, vertical, or diagonal, either direction. And nonlinear is going to be anything that's not. So a common one is parabolas, or you could have a function looking like this. So anything that's not a straight line is a nonlinear graph. X-intercepts are x values where the graph intercepts the x-axis, and that is written as number x, comma, 0. Y-intercept is the y value where the graph intercepts the y-axis. So to write that as a point, we do 0, comma, the y value. Domain should be reviewed as all possible x values, and range are all possible y values. We have been defining these two terms almost every lesson. This is very important for you to know. Increasing. The domain values where the graph increases from left to right. And decreasing is the domain values where the graph decreases from left to right. So we're looking at the x from left to right, how the graph is either increasing or decreasing. And behavior is a statement describing what is happening as the graph continues on. So we're looking at the arrows. So let's go over some examples. We have two graphs here. Let's take a look at the first one here. This line here, is it linear or nonlinear? It's a straight line, so it's a linear function. X-intercept, where does it hit the x-axis? So it hits right here. So that x value is x equals 3. And then we can write that as a point of 3, comma, 0. Y-intercept is where it hits the y-axis, so it hits right there at 3 as well. So it's going to be y equal to 3, and then as the point 0, comma, 3. Now for increasing. Let's look at this graph from left to right. Is there any points of this graph that it's increasing in value for the y? There's not, so there's none. Now decreasing, if we go from left to right, this graph is going down, so that's decreasing. So we have an arrow, so it's going to be decreasing from negative infinity of our x all the way to positive infinity in our y. Now let's describe the end behaviors. So let's look at x here. As x increases, what is happening? Our y is decreasing, so we can write that. So as x increases, y decreases. Okay, let's look at this function now, this graph. Is this a linear or nonlinear graph? It's nonlinear due to it not being a straight line. X-intercept. the x-intercept's where it hits the x-axis, so we hit it here and here. So we're going to have x equals over to -2 and x equals 0. And then as points, we can write that as -2, 0, and 0, 0. And it's okay to have more than one intercept. Y-intercept's where it hits the y-axis, and it hits also right here at 0, 0. So y is equal to 0, or the point 0, 0. It's okay to have the same x and y intercept at the same point. No big deal. And that would only happen at 0, 0. Okay, now let's look at if this graph is increasing or decreasing. So we're going from left to right. Here to here, it is decreasing. We split it right down the middle. And then from this point going up, it's increasing. So our increasing value is the turning point right here at -1. So we go from -1 to positive infinity. And then decreasing, we're going from negative infinity to a -1. Now let's describe the end behavior. So as x approaches negative infinity, so we're looking at this arrow right here. So as x goes towards negative infinity, what is happening? As x goes towards negative infinity, the graph is going towards positive infinity. So the graph itself is going towards positive infinity. Now, let's look at our second arrow here. As x goes off to positive infinity, what is happening? X goes to positive infinity, the graph is going to positive infinity as well. So our end behaviors here, no matter what x is doing, the graph itself is going to positive infinity. So let's look at some graphs here, and we are going to be relating the x and y. So we have gas in gallons and time in days. What are the variables used in the graph? Time and gas. What could you title this graph? I would title it, how long does your gas tank last? Now we need to see what is happening and to identify key parts of the graph. So this part right here, it's a straight line. So what's happening? There's no decrease or increase of gas, and we're spending a amount of time. So this is a constant. Same thing as here is also constant. So what those mean is the car is not moving. It's not using any of its gas. Then let's look here. This part right here. It's dropping down quickly. So this person used a lot of gas. While here, this decrease is a gradual decrease. So let's think how to write this. So they used little amount. So each section here describes how much gas this person has used in the amount of days. Okay. This table here shows the total number of customers at a car after 1, 2, 3, and 4 days of its grand opening. What graph over here can represent this data? So let's look at this. Day 1, there's a total of 61 customers. Then day 2, there's a total of 125 customers. What's the difference between day 1 and day 2? The difference of 64 customers. In day 3, we had 177 customers. What's the difference between day 2 and day 3? That would be 52. In day 4, we had 242 customers. So what's the difference between day 3 and day 4? That would be 63. So let's look here. Day 1 through day 4, we are increasing the number of people. So this graph is increasing. This one is also increasing. This one is going down, so it's decreasing. Same thing as D, it's decreasing. So we do not want C or D because they're decreasing and we are increasing in our numbers and people. So we don't have our intervals shown, so we have to see which one's a better option between A and B. So here we have 61, then we go to 125, 177, and 242. So that kind of makes sense. Here, let's think. 61, 125, 177, and 242. That kind of makes sense too. But let's look at the difference between each day. So between day 1 and day 2, we had an increase of 64, then a smaller increase between the next 2 days of 52, and then about the same as the first 2 days of the increase. So between day 1 and 2 and day 3 and 4 should be about the same amount in between each dot. So here we have 1 and 2 and 3 and 4 should be about the same. Here, 1 and 2 and 3 and 4 should be about the same, but this part and this part aren't about the same. There's a difference there, so the best option is A. Okay, this last one. When Max jogs on a treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes, then slows to a stop and stretches. After this, he increases to a speed that's slightly lower than before and jogs at this speed for a short time. While So he jogs at the speed, and then he starts to slow down to a stop. So we need to draw a graph to represent this situation. So let's label our axes first. We are measuring amount of time, so minutes would go on the bottom. And speed would be our y-axis. So when Max jogs on the treadmill, he gradually increases his speed. So he gradually increases. Then it says he jogs at this level for several minutes. So he's at this level for several minutes jogging. Then he slows down to stop and stretch. So he's slowing down. And then he stops for several minutes to stretch. So here he's stretching. It's on the x-axis because he's not having any speed to be up and about. So it has to be a speed of 0. Then he increases his speed to not as high as before. And then he jogs for some time and then slows back down to stop. So that is a nice representation of Max's jog on his treadmill as a graph. So that's the lesson for today. Please reach out if you have any questions.